Hello, this is Professor Broker, and this is your Chapter 14, Lecture 1, Competitive Markets, Part 1. This is for Econ 231. Let's go ahead and get started. So, some questions you want to be looking for in Chapter 14, and questions you want answers to are, what characteristics make a competitive market, right? This is something we need to know. What defines it? How do competitive markets or firms in competitive markets decide how much output to produce? We're going to see that that's going to be one of their key decisions. How do competitive firms decide when to shut down temporarily, right? Production. How do they decide when to exit a market, which is going to be different from shutdown, okay? And then how does a competitive firm, their behavior determine a market's short-run and long-run supply curves, okay? Which we'll get to that at the very end. First, we need to kind of discuss what are the characteristics of a competitive firm. Right? Well, number one, there's many buyers and sellers. Lots of buyers, lots of sellers. Each buyer and seller is relatively small compared to the overall market. Okay? And then the goods offered for sale by the sellers are largely the same. These are two of the key characteristics of a perfectly competitive firm. Okay? And then the third one is that firms can freely enter or exit the market. When we say freely, we don't mean that they can just, necessarily do it for free. It might cost something, but the costs are very, very minimal, and it can happen relatively easily. There's no major barriers to entry in competitive markets. Now, because of the first two characteristics, okay, we come to the conclusion that these competitive firms are price takers, meaning they don't determine their price for their product. They take the price as a given. Let me give you an example in the real world. Right? You might think of farming, right? So if I grow something, if I grow apples or if I grow corn, okay, or if I grow wheat or soybeans, right, then I will harvest them and take them to market, and I won't have any pricing power, right? I will have to, for my bushels of corn, I will have to take the market price as a given. Why? Well, number one, no matter how big my farming operation is in Callaway County, I'm still going to be relatively small compared to the overall corn market in the U.S. and for that matter, the world. Okay, and my corn is going to be largely the same as corn grown in Graves County. So I can't go to market and say, well, my corn's significantly better, and so I deserve double the price. That's just not going to fly, right? I'm going to be a price taker, and I'm going to take that price as a given. Okay, another example that you might think of in terms of price taking is if you've ever been a part of the stock market, right? So let's just say you own 100 shares of Apple Incorporated, right? So Apple stock. This means that you're a part owner of that company and you can share in the profits and losses. Now, let's just say you want to go, maybe you inherited these or something, and then you want to go and sell them. Well, what price are you going to be able to sell these 100 shares for? How much money are you going to be able to make? Well, it's going to be basically determined. How much money you're going to make is going to be determined by what the market price is. Why? Because you aren't going to sell them below the market price, right? I mean, because of course, you'd be leaving money on the table. So if the market price is $100, you're certainly not going to sell them for $20 a share unless you were doing it for a friend or something, right? Because that would be leaving money on the table. You're going to make as much. You want to make as much as possible. So you wouldn't sell it below the market price, but you also couldn't sell it above the market price. Right? Because if, say, the market price, right, of Apple shares is $100, and you come into the market and you say, hey, I'm selling mine for $200 a share, no one's going to buy it. Why? Because your Apple shares are identical to millions of other shares of Apple stock that are for sale in the market and that are bought and sold every day. And your 100 shares are very, very small compared to the overall market. There's millions of shares bought and sold. And so again, this is a good example of you being a price taker. You would simply have to take the market price as a given. That's what you could get for your 100 shares. Okay, and it's also true. You're a price taker. That's also true for our perfectly competitive markets. Now, let's just do some formulas and just some basic relationships here. The revenue for a competitive firm, we're going to call total revenue, TR, is simply going to be the price times quantity. If I go and I'm selling ice cream in the Quad at Murray State, the price I'm selling my ice cream cones for, let's just say it's $2, times my per cone times my quantity of 100 is going to give me my total revenue, right? 2 times 100 would be $200 total revenue. Okay? My average revenue, what is my average amount of revenue per ice cream cone I sell is simply going to be the total revenue divided by the quantity. Now, if you think about how we derive total revenue, right? Then price times quantity, if I divide price times quantity by quantity, right, then these quantities will cancel out and I'll be left with price. Therefore, average revenue will equal our price for a single price firm. Okay. Now, what about marginal revenue? Marginal revenue is simply going to be the change. How much does my total revenue change as I change my output? Specifically, as I increase my output by 1 unit, how much does my output change by? That's the question I want to ask. Well, let's apply these concepts in a little chart here, right? How am I going to find my total revenue? Remember, it's price times quantity, so I take my price times my quantity, okay? And 10 times 0 would be 0, 10 times 1 would be 10, 10 times 2 would be 20, and so on, right? So that seems pretty straightforward. Okay, what about my average revenue? Okay, well again, remember, my average revenue is simply going to be my total revenue, okay, which we won't worry about 0 quantities there, but my total revenue divided by quantity. So 10 divided by 1 would be 10, 20 divided by 2 would be 10, 30 divided by 3 would be 10. Or remember, I also told you average revenue equals price, and so I could just plug 10 in all the way down for average revenue. Okay? Something else I want to point out is notice that as I'm increasing quantity, my price is not changing. Okay? Remember, that's a function of the fact that we are very small compared to the overall market. This would be like a corn farmer, right? If a corn farmer grows an extra acre of corn in a given year, the fact that that corn farmer is going to produce more corn, that's not going to change the market price for corn because, again, he's very small compared to the overall market. And that's true for our competitive firm, which we see here. As we increase output, the price is not changing. Okay? Now, marginal revenue. Let's look at this. Remember, that's as I increase output by 1 unit, say from 0 to 1, how much is my total revenue changing? Well, go from 0 to 1 output, my total revenue is increasing by $10. Go from 1 to 2 units, my total revenue is increasing by another $10. 2 to 3, increasing from 20 to 30, another $10. In other words, my marginal revenue is 10 all the way down. Now, what is that also equal to? Okay, well, it's also equal to my average revenue, which is also equal to my price. Okay, that's a key indication, or that's a key relationship that I want to point out here. For our perfectly competitive firms, and only for our perfectly competitive firms, marginal revenue is actually going to be equal to our price. Okay, and that's an important relationship to remember. Okay. Average revenue will be equal to price in every market. We'll look at monopolies later in chapter 15, and we'll see that for a single price monopoly, average revenue is going to equal price, just like for our competitive firm. But only for competitive firms, perfectly competitive firms, does marginal revenue also equal the price. Okay? And so you're going to want to commit that to memory. That's an important relationship. Now, how does our competitive firm determine their profit? Remember, they're not going to be determining price. They're price takers, but they are going to be determining their output. So how much output do they want to make? They want to make enough or the right amount to maximize their profit. Remember, that was what we assumed. That's what we are assuming our firm's goal is to maximize their profits. Okay, we learned that in chapter 13. So we want to find the quantity of production that maximizes our firm's profit, and to find that, we're going to think at the margin. Okay, we're going to think at the margin. So actually, I'm going to go ahead and put the profit numbers up here, right? And you can see immediately that in between 3 and 4 units, right here, that maximizes our profits. But to arrive at that, because we don't always have this data, all of the data for all of our production points right in front of us. But what we do typically know is how much does the next unit of production cost us? How much does the next unit of production how much does it bring us in terms of revenue, right? And those are marginal pieces of information. Okay, so what we want to do is we want to compare if this firm makes nothing, and then they go from 1 unit, from 0 to 1 units, right? They decide they're making a decision about producing that first unit. How much does their revenue change? Well, their revenue changes by 10. They get an extra $10 for producing and then selling that first unit. And it only costs them an extra $4, right? Their total cost is changing from 5 to 9, right? Obviously, they have $5 of fixed cost, right? Which is why even when they make nothing, they still have some cost, okay? But as they go, the change in total cost from 0 to 1 units is 4, okay? So again, you think, is the extra benefit, the revenue, greater than or less than the extra cost? Well, of course, the benefit is greater than the cost. In fact, it would increase their profit by $6. That would be the change in their profit. The first unit would be beneficial. Okay? So we would assume that the firm would produce that first unit. What about the second unit? Well, the second unit will again net them $10 because they will be able to sell it for the market price. Okay, that extra unit going from 1 to 2. But that second unit will cost them an extra $6. Okay, a marginal cost of 6. Well, is the extra benefit greater than the extra cost? The answer again is yes. It would increase their profit actually by $4. Okay. And so the second unit would be beneficial. So we would assume the farmer would go ahead, or I'm sorry, this producer would go ahead and produce. What about the third unit? As we go from 2 to 3 units, well, again, the extra benefit is $10. And if we compare the total cost change here, we see that the extra cost is $8. Again, the extra benefit is greater than the extra cost. It would actually increase their profits by 2. Therefore, the third unit is profitable for the farmer or for the producer. Okay? And then what about the fourth unit? In this case, it looks like the extra benefit is exactly equal to the extra cost. Okay? So it would basically leave the profit unchanged, but it wouldn't decrease our profit. And in these examples, I want us to get in the habit of thinking of the farmer or the producer is going to produce as much as they can without decreasing their profit. Okay? So they would go ahead and produce this fourth unit, right? Exactly where marginal revenue equals marginal cost. Let's look at the fifth unit. We see that the fifth unit would increase revenue by 10, but it would also increase cost by 12, and it would actually lower their profit by 2. So we see very clearly that the producer would not produce the fifth unit. It looks like, right? How did we find our profit maximizing quantity? Well, before we get there, one thing we notice is that when marginal revenue is greater than marginal cost right here, right? 10 is greater than 4, 10 is greater than 6, 10 is greater than 8. How could the producer make more money, make more profit? Well, by increasing their output, right? But what about when marginal revenue was less than marginal cost, like right here? Then how could the producer actually make more money? Well, by decreasing output from 5 to 4, right? And so we see that the profit maximizing quantity was actually found where marginal revenue exactly equaled marginal cost. Okay? And let's look at this graphically. Okay? So here we have an upward sloping marginal cost curve. We have a constant marginal revenue curve. Remember, that's for a competitive firm because marginal revenue equals price. And we see here at Q1 that marginal revenue is greater than marginal cost, right? And we saw numerically that the farmer or producer would actually benefit by increasing output, right? But what if they increase it too much? And then where marginal cost is greater than marginal revenue, like at Q2, well then the producer would be wise to decrease output until what point? Until Q star, exactly where marginal cost equals marginal revenue, right here. That is our profit maximizing rule. Okay, so this is another important relationship to memorize, to commit to memory. Okay, our profit maximizing rule for our competitive firm is where they're going to produce output where marginal revenue equals marginal cost. Now let's go ahead and apply this. Let's just say that you get a job at a factory. Okay, and you're making little widgets, and you're currently producing 500 units, and here is your cost structure, right? At 500 units, your average cost per unit is $200. To make the 501st unit, your average cost would increase to $201. Okay, let's just say you get a call from a customer that you're already producing 500, and they want you to produce one extra unit, and they will offer you $450 for that extra unit. Okay. Should you accept the offer? Again, you're the night manager, and you're trying to maximize the firm's profits. That's your primary goal. What's going to be, if you accept this offer, what would be the change in profit? And then what's the relevant comparison, right? Some people might think the relevant comparison is, we'll compare that 450 to the average cost of that 501st, unit, and, obviously the 450 is greater than 201, so you should do it. But is that the relevant comparison? It's not. Remember, we want to think at the margin. Well, what's the extra benefit from accepting this offer? Well, if we accept the offer, we're going to get an extra $450 for that 501st unit. So that's the marginal revenue. But what's the marginal cost? Some people think it is $1, right? A change from 200 to 201. But that's representing our change in average total cost, which is not how we measure marginal cost. How do we measure marginal cost? We measure it as a change in total cost. So we need to calculate total cost. We can find total cost by multiplying average total cost by quantity. 200 times 500 would be 100,000. That's your total cost for producing 500 units. And then if we multiply 201 times 501, we see that the total cost for producing 501 units is actually $100,701. In other words, what's the change between producing 500 and 501 units? The marginal cost is actually $701. In other words, to produce that extra unit, it would cost you $701 and you'd only get $450 of benefit. That would actually decrease your profit by $251. This would not be, just from a purely profit maximizing point of view, this would actually not be beneficial to accept the offer. You wouldn't want to do it. It would decrease your firm's profit. Okay, when you look at this using the relevant comparisons, marginal revenue and marginal cost. Now let's look at how we can find profits and losses graphically. Okay, so we need to understand some relationships here. First, remember that profit equals total revenue minus total cost. Okay, but we can rewrite that, right? If I rewrite total revenue as price times quantity, okay, isn't that still total revenue? Of course it is. We can also rewrite total cost as average total cost times quantity, which we just looked at in the last example, right? So this also is going to give us total cost. We're just rewriting these terms up here. Now, if we do that, these two terms, what do they have in common? How about quantity, right? They have quantity in common. So how about we pull that out and factor this a little bit? We end up with the relationship of quantity times price minus average total cost, right? We're simply rewriting this relationship, which we were in this equation, we were simply rewriting this relationship. So this is still, the point is that this is another legitimate way to find profit, right? Quantity times price minus average total cost. Okay, and that's going to be important when we look at this graphically. Okay, now this is going to be your kind of your three-step process for finding profits and losses on a graph like this. When I give you a marginal cost, price and marginal revenue, and then an average total cost. The first thing you want to do is find Q star. Well, where's Q star? Q star is going to be your profit maximizing quantity, which is where marginal revenue equals marginal cost. Take that down to the x-axis. That's your Q star. Then you're going to find price. Price is easy because, I mean, it's just whatever the price is. We take it as a given. So we just take it over, and then boom, whatever the marginal revenue is, that's also what the price is. Okay, then we want to find average total cost minus quantity. Now to do that, okay, we're going to simply find where our Q star is, and at that quantity, take it up vertically, or down for that matter, okay, but up vertically to the average total cost curve. And then take that over, and then boom, that's going to be the value of our average total cost at that particular quantity, Q star. Okay? And then we simply would plug in the values that we found, right? Our price, our quantity, Q star, and then our average total cost to our new profit function that we derived. Okay? So let's apply this. Now we're not going to use any numbers in this case, but we can just see visually, right, that, okay, find where marginal revenue equals marginal cost. That's going to give us our Q star. Okay, our price, which is also our revenue per unit, is going to be right there. Okay, and then we see this dotted line right here. Along that dotted line, which is our Q star, what's the value of average total cost? Well, boom, right there, that's going to tell us. Okay, now how do we then plug those values in? Okay, well, again, you just plug in quantity. You find the difference right here between price and average total cost, and multiply that by quantity, and therefore visually this rectangle right here will be our profit for the firm. Okay, that geometric shape right there would give us the value of our profit. And again, it's profit because our revenue per unit is greater than our cost per unit. Price is greater than average total cost. Okay, when price is less than average total cost, you're going to use a similar process, but you're actually going to be calculating losses. Okay. Now, here's an example, right? Let's use our three-step process. Okay. So again, find Q star, which is where marginal revenue equals marginal cost. Okay. Then find price. Okay, which is going to be our revenue per unit. Okay, right here. Then where quantity is, take that up or down to average total cost. In this case, right, we take it up to average total cost, which means price is less than average total cost, which means when we plug in these values, this is going to be negative,
Multiplying that by quantity is going to give you a negative number, which means it's going to be, that rectangle is going to represent the loss per firm. Okay? Now, one final thing, what happens if more people are buying the widgets that we're producing at the factory we were talking about, right? Well, let's talk about it in the market context and then apply that to the firm context, right? When there's more people buying the widgets, right, use our three-step process from chapter 4, what would happen? The demand curve, right, would shift to the right. Now, this is the market. What would happen to the market price for widgets? Increase in demand would increase our price from P1 to P2. Remember that? Okay? So let's apply that to our widget firm. Remember, if this is a perfectly competitive market, they take the market price as a given, which means they will now notice that the market price they can get for their widgets has now gone from P1 to P2. Now, that being said, right, again, the price has gone there. If they continue, okay, now remember, at the old price, Q1 was the profit maximizing quantity because that's where marginal revenue equaled marginal cost. But now at the new price, right, that old price vanishes. Is Q1 still the profit maximizing quantity? No. At the new higher price, P2, for the competitive firm, marginal revenue is now greater than marginal cost, which we can see here, which means Q1 is not our profit maximizing quantity anymore. So to get to the profit maximizing quantity, where marginal revenue equals marginal cost, over here, what does the firm need to do? The firm needs to increase output, right? And that's exactly what we would predict they would do if they're rational, right? Because they could make more money. So they would increase their firm output, right, from Q1 to Q2, okay, moving up along their marginal cost curve. Meaning the marginal cost curve is the competitive firm's supply curve. The marginal cost curve is the supply curve for the competitive firm, okay? Because that's what they're going to be using. They're not going to be determining price, but as the price changes, they're going to be utilizing their marginal cost curve to determine their profit maximizing level of output, just like we saw in that example. Now, applying that over here, remember, in chapter 4, we said when demand increased, the price goes up. Remember, we also get an increase in equilibrium quantity. Where does that increase come from? Remember, we said it came from this increase in quantity supplied along our existing supply curve. But where did that come from? It came from, remember back on the previous slide, the fact that the individual competitive firms, are increasing their output because of the increase in price, right? It all goes together. The competitive firm's decision is linked to what we see in the market, right? This increase in quantity supplied. Thus, we can also determine what really is behind our market supply curve. Well, what's behind our market supply curve, in essence, is all of our individual firms' individual marginal cost curves. In other words, our supply curve is really sort of a summation of all of the marginal cost curves for our competitive firms. Okay, so hopefully you see how those two concepts now go together.